Hi everyone. The first case I chose was case 2 about the 16-year-old female that was recently diagnosed with the deficiency of methyl glycogen phosphorylase. So, the first question that asked was how methyl glycogen is normally used during exercise. So, glycogen is a form of glucose, which is a sugar that is not immediately used in our body after intake. It's stored in the muscles and stabilizes blood glucose levels. But whereas methyl glycogen serves mainly as a source of metabolic fuel for your muscles. Your muscles need lots of energy to function in order for you to move. If your muscles relied on glucose from your bloodstream for this energy, your body would quickly run out of glucose. The rate in which your muscle glycogen reduces is closely related to the intensity of physical activity. The greater the exercise intensity, the greater the rate when methyl glycogen runs out. So during exercise, the glycogen molecules are broken down into simple glucose molecules with the help of methyl glycogen phosphorylase enzyme for the body to utilize. So, when taking a long walk, it can cause excessive fatigue, muscle cramps, muscle weakness, pain throughout your joints, that as the body is unable to utilize the stored glycogen. You can still take long walks, but make sure you have a source of glycogen or glucose with you whenever you're beginning to feel tired or whenever you feel those cramps and the weaknesses come on. If you are eating a nutrient-rich diet for dinner, the glucose that is released is enough for your body to utilize throughout the night. The deficiency of the methyl glycogen phosphorylase is that your body is not able to utilize glucose once it's converted into glycogen, but it can use it in the form of glucose. Once it's converted, it is used only in a demanding condition. So when you're sleeping, you usually don't get up at night to maintain your blood glucose levels, but you can definitely have some sort of a glucose beverage, some glucose containing snack, just in case your glucose levels fall. Yes, you need to be worried about producing excessive lactate. McArdle disease limits the amount of anaerobic and aerobic exercise capacity. It limits you on how much you can endure, but don't completely shut out exercise in general. Just be mindful of how much and how long you're doing those anaerobic exercises. So I also chose case 4 that deals with the 2-month-old baby. So based on the information that was provided, the baby is most likely suffering from glycogen storage disease, which is the inability to use glycogen. Given the symptoms that the baby is presenting, such as the enlarged liver, the low blood sugar level, and a high level of lactate, it can be further concluded that the baby is indeed suffering from glycogen storage disease. This disease is rare, it's inherited, meaning it's passed from a parent to child. And this condition is just basically in which the baby is born without certain enzymes that are necessary for your body to make and break down glycogen. The specific enzyme that we're talking about is myophosphorylase. But your body also uses many different enzymes to process glycogen, and along with that, there's several types of GSD. GSD can also result in liver damage and muscle weakness. So when looking at the other three intolerances and deficiency diseases, that sort, none of them, there's only like one that was kind of similar, but the other three did not touch close on what the baby was suffering from. So I'll just go through each of those and kind of explain what it is and the symptoms. Glycosema is when galactose 1-phosphate, probably going to butcher this, uretrotransferase, also known as a GALT, so glycosamina is when GALT is missing or not functional. Therefore, the liver enzyme is responsible for breaking down lactose. And galactose is a sugar byproduct of lactose found in basically any type of milk, including breast milk, cow's milk, dairy foods, cheese, cottage cheese, ice cream, so it's that sugar byproduct of lactose found. It's responsible for breaking down galactose into glucose, and those types of milk and dairy foods that I listed is just one of those sugar byproducts that lactose is found in. So the symptoms of galactosemia is kind of like the refusal to eat, spitting up, vomiting, jaundice, lethargy, and cataracts, in which the baby is not presenting any of those. He's just jittery. He's sleeping a lot, and he has a enlarged liver. So looking at glucose 6-phosphate deficiency, it's a genetic disorder that affects red blood cells. And this disease causes basically the red blood cells to break down prematurely, faster than what our body can make them. So it results from mutations in the G6PD gene. It leads to hemolytic anemia, in which like I said, the red blood cells are destroyed faster than in which our body can replace them. And the symptoms of this, it can lead to paleness, jaundice, dark urine, fatigue, shortness of breath, and a rapid heart rate. None of which the baby is presenting symptoms with. So hereditary fructose is just intolerance, and where patients lack the enzyme to break down fructose 1-phosphate. The symptoms that occur from this intolerance is nausea, vomiting, jaundice, and hypoglycemia. So this is kind of the one that I was also thinking about, but I led more towards the glycogen storage disease, because the baby was presenting more symptoms of that than the other, basically because of the enlarged liver. but it didn't, the baby wasn't presenting jaundice, he wasn't vomiting or anything, so that's what made me come to the conclusion that he was suffering from glycogen storage disease.